Hi all, in this video I'm going to show you the behavior of materials under deformation can be described by the following mechanical properties. Let us see some important mechanical terms. Under deformation. Strength. Strength is the ability of a material to withstand a force without breaking. How about stiffness? Stiffness, resistance of a material to changes in shape or size. Elasticity. Elasticity of solids is defined as the property of a material that enables them to return to their original dimensions after an applied force has been removed. The dimensions here is about shape and size, and the applied force here is about stress. Deformations occur when external forces act to stretch, compress, or shear a solid. Ductility, tendency of material to change its size and shape considerably before breaking. And brittleness, tendency of a material to break without deforming. Table shows the examples of elastic and inelastic materials. For elastic material is about sponge, spring, rubber. Whereas for inelastic material is about paper, metal and plasticine. Here we're going to see some examples for ductile materials and brittle materials. Ductile materials undergo plastic deformation before breaking, such as steel, copper and aluminum. And brittle materials do not show plastic behavior deformation, such as glass. Table showing you the comparison between elastic and plastic deformation of a wire. For elastic deformation, the extension does not exceed the elastic limit of the material, whereas for plastic deformation, the extension exceeds the elastic limit of the material. For elastic deformation, when stretching force is removed, the wire returns to its original length, whereas for plastic deformation, when stretching force is removed, the wire does not return to its original length. The wire is permanently lengthened. So here, for elastic deformation, the internal structure of wire does not change, whereas for plastic deformation, the internal structure of wire changes. Elastic deformation obeys Hooke's law. When Hooke's law is obeyed, the energy stored during elastic deformation is fully recovered when the force is removed. Whereas for plastic deformation does not obey Hooke's law. During plastic deformation, energy is converted into heat. Figure shows the stress strain graph for steel, glass, copper and aluminum. Glass does not undergo plastic deformation. Materials which undergo plastic deformation before breaking are ductile. So steel, copper, aluminum are ductile materials. Ductile materials undergo plastic deformation. Brittle material like a glass just break after elastic limit is reached. Just shatter like a glass. No give and take. It is just break like that. That we call it brittle materials. Now we're going to show you force, extension and stress strain graphs for ductile material. You have two ways to sketch the graph. For force against extension or the extensions against force. Let us begin with the process of OA. When the force is small, the extension E is directly proportional to the force F. The wire obeys Hooke's law. So from O to A, the wire shows elastic behavior, so-called proportionality limit. B is elastic limit of the wire or any ductile material. At this point, the wire returns to its original length along path BAO when the force is removed. Beyond this point, the wire is permanently stretched and sadly will never regain its original shape and length. If the force on the wire is removed at C, the wire has a permanent extension of OP. So point C, we call it yield point. Yield point mark a change in the internal structure of the wire. So plastic deformation starts at this point. When a force on the wire is further increased, extension increases rapidly. At point D, force is maximum, or we call it stress is maximum, and D is also known as the breaking stress. And finally at E, the wire breaks or fractures. Now we're going to see stress strain graph, which is quite similar to force extension graph, which showing you all the points which I described before: O to A, B, C, D and E. And point A is proportionality limit, B is elastic limit, C is yield point, D is point of maximum force, and E is fracture. So you can see from O to B is elastic deformation, and from C to E is a plastic deformation. So we have two processes undergo by ductile material, from elastic deformation to plastic deformation before it breaks at E. If the force on the wire is removed at C, the wire has permanent extension of OT, like what I explained before for force extension graph. If the question asks you to sketch a graph of stress against strain or force versus extension, it is very simple. We just have to draw a straight line to show it obeys Hooke's law, and you're going to put small hill and big hill. This is stress and this is strain. So this is O, A, B, C, D, and finally is E. Very simple. Straight line, small hill, big hill. Simple like a bubble without giving you any trouble. And you can apply the same technique for force against extension. Then you're going to label all the points in this graph from O to E, exactly like this. So you can put it this way: A is proportionality limit, B is elastic limit, C is yield point, D is point of maximum force or maximum force, and E is fracture point or breaking point. Simple, like a bubble, without giving you any trouble. Thank you for watching this video. Thanks a lot, and thank you to the Lord.